Okay, I hope you all have a good weekend. There's a few things I would like to announce before I go into today's lecture. Number one, this afternoon for discussion hour, I'm going to cover homework 4. If we have time, we'll go to homework 5. Number 2, please get going in terms of forming your group. I hope sometime, the protocol is like this. I'm expecting you to send me an email regarding all the members in your group. I just need the group membership at this point. So try to send to me before this Friday about your group. If you have any trouble finding the group, you also send me an email, and such that I can help you to pair it with other group. They're either still looking for 1 or 2 members and things like that. Some of the group, maybe I can merge you to at least to talk about what your interests. Okay, so that's for the final project. And if you have your group, then starting this week, you can have a meeting with me. It's usually about half an hour meeting. We can do any time during the week. Is probably easier for us to meet right after the class. So for example, today, if you're interested, you can come talk to me after the class. If you already have a group, I can start helping you to, that's my first meeting. And usually I will help you to very quickly converge to the area and help you to further your discussion. All right, that's the group project. The other thing I do want to mention is that I will send you a program. That's the program I will be using to decide how I'm going to assign the grade. So it's a C program converting the points you'll receive toward the end, and then how I'm going to decide whether your grade is, A, B, C, D. So you will have some idea about how I actually allocate the grade. But I do want to say the reason I brought this up right now is that I want to say thank you for all your hard work and try to push homework 3. I know it's a hard homework and it's challenging, but I really want to praise for your attitude and your the effort you spent in making this happen. So when I grade a student's for evaluation assessment for a student, I'm actually not only look at the correctness of your program. I look a lot about your effort put into the learning process. That to me is much more important than anything else. So I actually, based on what you have done as a team, which really work together, is part of your discussion in Discord, which I have no idea because I don't want to go into that space to take a look. But I believe there is a lot of help and interaction, maybe some frustration there as well. You probably will share with me later. But anyway, that's okay. But I'm actually adjust the score because I'm not doing curving, as you probably already heard me saying that. So I basically make a bar. The program actually show when to have that bar. So essentially, I'm giving everybody 2%. So I'm lowering the bar by 2% because I think you deserve to have actually a good grade based on the effort you put it in. So that's just want to tell you. You will receive the program. You will see what was the original bar and what's the current bar right now. Because that is not because I lowered the standard. That's an easy way for me to actually give you a small reward for your effort that you put it in. Okay. All right. So I hope you can keep the good work and for homework 4, 5, and 6, 7. And I think that homework 3 might be the most challenging. It's not necessarily the time you need to spend, but it's the learning, the concept. There's just so many things putting together. You have a virtual function, you have remote procedure call, you have a web programming, you have all the JSON representation. So those 4 elements put together really is just conceptually really challenging. But I hope you learn a lot, and the subsequent homework will kind of repeat some of the concepts. But right now you're not like a freshman to deal with that. So you should be able to just take a less effort, but still you will be learning something new over there. All right. All right, so I'm actually going to talk about a new topic right now. Where's my slide? Is here. I'm going to talk about template in C++. Yes.
So you said
Email, the real email to whatever this email address. To this email. Yeah. That's okay, but I still hope to have an email so I keep it a record. So sometime you tell this, and I forgot one member, and I might be panicking. So I hope that email helps you too.
So do you want like first name, last name?
That email, of course, will have everybody's email address. So I will be able to contact the group, the email address, the name of the student, and also the student ID. So I will be able to do the grading. So I basically have that as a recording.
Another question is
Okay. Homework 2, the TA, just let you know, I forgot to mention, homework 2, TA is not going to grade it. I'm going to grade it. Homework 2. I'm actually going to dig through the JSON file you submit, and then I will do homework 2. Yeah. Because I want the TA to focus on homework 3. So homework 3 will take a lot more time than to grade. Homework 2, if you think about that, for me to grade, the reason for me to grade is I'm going to write a program to grade. It's just see if you have done this and that. Okay. All right, any other question? So just to let you know, because later you might have some issue with each of the grades. So for homework 1, go to TA first. If TA cannot resolve, then you bring the whole case to me. Homework 3 is the same thing. Homework 4 is the same thing. 5, 6, 7, I haven't decided because 6 and 7 is essentially a group project. So so typically homework, I did once that essentially I asked a student during the final project, they actually showed the result. They're 6 and 7. That's very easy for me to see that. But 3 is definitely go to the TA. All right. So we're going to talk about the template, which is we're going to cover essentially 3 parts of this. We're going to cover, they're related. I mean, the ultimate goal is actually go to chapter 16. Is about the class template, but this is related to 2 other chapters. Now we're going to cover 2 chapters before chapter 11, which is chapter 8, which is a function template. Because you're going to, in order for you to know how to do class template, the first thing you should learn is how do you do function template. Some of the instructor in ecs36b, they have cover function template, but typically we don't do that. So you might find some duplicate, but I'm going to cover function template anyway. And then chapter 9 is a very important unique topic for lambda expression. So those topics are related to help us to put together a nice class template. All right. So before I go into, so this is what I'm going to talk about in this next sequence of lecture, probably starting today, is about function template, class template, and then I'm going to talk about standard template. Like you have been using like std vector, std map. Those are the most powerful template. That's if you use the C array, you realize that C array really sometimes you have to be careful as a C programmer. But I would say using this template, standard template like vector and map, the chance that you will make a mistake will be less because the template already provide a lot of like a chance, and in some cases like vector, you don't need to worry about like a boundary of the array. It's been taken care of for you. Okay, so before I talk about that, I actually want to switch to another topic because this is related. In order to deal with this, I need to provide some background knowledge. And not this slide. Where's the other slide? Yes, I want to actually go through some of the pointer and reference. When I first talked about shadow object, I never talk about this part, but I want to address some of this because eventually this will lead to pointer to the function. Eventually, you will see that there's a lot of topic. You'll be clear if I talk about this a little bit. So very quickly, I'm going to review some of the material in ecs36b, but not necessarily that you already know this because until now, you're going to address more of the segmentation violation issue, which is related, especially if you're homework 4. Okay, I know why I need to talk about this here. This is actually somewhat related to homework number 4. So this is a typical computer hardware. I'm just reviewing the pointer that essentially you have a bunch of hardware component in your computer, a modern computer. But the most important part about this board is where is the location. You're going to save your object or save your array or save your whatever memory that you have. It's typically some of this is called memory bank. That's actually the 4 memory slot. I put it there. That's actually allow you to put certain things there. So each of the memory has a location. So this location is not, of course, it's not a GPS location, but has like a mailbox address that we talk about. This address issue is that is the location. So essentially, where do you really locate your the place that you actually put your data? For example, in this case, I actually put it in miles. For example, you're getting get distance, and then you have some kind of distance number, but where do you actually store that number? That's what we are trying to help. So let me just give you an idea about address. The address looks like this. If it's a 32-bit architecture, it has 32-bit address. You can see that those represent, this actually represents a hexadecimal 69B1E087. That's basically your hexadecimal representation of that 32-bit address. But the thing is that I want to show you a little bit about programming is how do you actually access to that? And I hope you remember this. This is essentially a scanf. And if that miles variable is a variable you want to use, when you add n, that actually represents whatever address. The first, okay, by the way, I just want to ask you a question. What do you think the data type of the miles? If I show you this piece of code, what should be the data type of this variable miles? What? It could be either float or double, right? Because f, well, if I use LF, it's probably double. Because if I use just %f, that means it's a floating point. But I use %LF, it's actually usually it's a double precision floating point. Okay, my follow-up question to you is that, well, how many bytes do we need to store a double? How many bytes? 8. How do you know? No. Well, don't look at the number. Okay. How do you know it's 8 bytes? Yes. Yes. Okay. That's a good answer. In fact, to determine how many bytes double is never clear. is really hardware dependent, the platform dependent. So in C program, as you said, there is a way to check is for size off. You always use the function size off to find out what's the size of this particular data type, like the basic floating point, or it's an object. You want to say, well, how many bytes? Now, actually, I will show you. It's interesting to use size of to realize what is the size of an object. That's actually fairly nice for you to do that. So we don't know how many bytes, by the way. It really check. I mean, you will be surprised when you porting a software from one machine to the other machine, different operating system. You realize why your program no longer works. And sometimes it's because you assume is 8 byte or 4 byte or whatever bytes. And the thing is that it is not. And therefore, the program will work for one machine. They will not when you port it to a different machine. So that's a very important for you to be careful as a C++ programmer. Okay, so when you put that m in front of the variable, it actually changed from the content of the variable to the address of the variable. So essentially, if this platform, that double is actually the 8 byte, then that address is going to be first byte, the address of the first byte, because every single byte has an address. There's no skipping. Okay, basically each address location is pointing to one particular byte. That's why there are 8 bytes. I list the 8 address to represent this double, but when you say M sign, it's actually going to pointing to the first byte. Okay, that's the representation. So therefore, that statement over there, I said scanf %lf m miles. You can actually just type in like this. If you actually realize that that's actually what's the address, assuming that's the same system, same program, then essentially that statement is equivalent to this statement. In fact, you can actually write the statement exactly like this to actually print it. I mean, to be honest, a C programmer, you can do a lot of crazy things like this. It doesn't make sense, it's completely unreadable. But I will actually show you some really interesting examples. Sometimes it makes sense for you to actually write a program that looks like this, but I'm not going to show you. It's an extremely rare case that you need to do that. Okay, but those two are essentially equivalent. Address, okay, in C, just let you know, address, pointer, and array, they're actually the same thing. That's confused. Let me repeat it again. Address, pointer, and array, they're actually the same thing. All right, so I'll show you an example. You can see that how, because it's related to the template that we have to address. Okay, so essentially what you have is such kind of memory, this, and then size off. This is how you can get size off. So you can actually print a program that, for example, the third line, not the fourth line, the third line is, okay, you just say size of double. You put, okay, by the way, in the size of, you can put either a data type, like here, I'm putting 4 data types, but you can also put a variable name there. You put a variable name there, or you can put miles there, or you can put n miles there, n sign and mile. You can put anything there in the size of, and size of will actually return to you whatever number of bytes for them to represent every instance of that data type or that particular variable based on the data type that the compiler interpret the variable, whatever you put in there. It will calculate the number of bytes. That's why I said you can actually put a class there, you can put a struct there, or you can put an object like say homework 3, you have this object called HW3 server. You can put a server there, address, and it will calculate how many bytes it will take. Okay, so that's the That's the memory box concept, and that's the address. Okay, so this is a little bit challenging, but I just want to go through this. And this is what we call the memory map or memory cell layout. So every single program that's actually being allocated in a typical operating system like a Linux, Windows should be very similar in terms of this layout. Is essentially from the lowest address starting from 00000 all the way to the maximum amount of address that you can have with whatever what we call the architecture you have. For example, this is architecture. The way I wrote address is 1, 2, 3, 4, 5, 6, 7, 8. This has a decimal representation. So this actually represents a 32-bit architecture. So this picture is showing a 32-bit memory layout from the lowest address to the highest address. Okay, so for Python programmer, you really don't need to know this. But for C programmer or C++ programmer, we actually have to know this. So I want to actually show you there are two regions of memory that's actually mostly critical to your program. One is called user stack, one is called heap. So user stack and heap is different is that in the user stack, when you want to call functions, say main call scan address call scanf, and when you call the function that there is something called stack element being accumulated down this way. And then there is another area called heap. The heap is essentially saying that, okay, anytime you do malloc or free or new and delete, it will actually use the memory address in this region called heap. That's why sometimes you say, well, where do you actually get the memory? Is this on the stack or on the heap? So now graphically, you know that that's basically you set up the different region of the memory. By the way, this memory is huge. For 32-bit computer, the memory addressable memory is 2 to the 32, roughly. So 2 to the 32 is about 4 GB. So every single program that you have, so if you're running 200 programs on this computer, you basically have 4 gigabytes of memory, virtual memory. We call it virtual memory, even though your real memory is probably much smaller, but you're talking about 2 to the 32 bytes of memory that allocate. So every program have that. I want to show you something, which some of you saw me doing that. This is a nice facility for Unix environment that really help you to understand what your system is doing. So when I first came here, I actually realized my system is slow. So I use this command called top. So top essentially showing me all the processes are running, how much memory they are, where's the memory? Yeah, how much memory they're using, and how much CPU they're using. So I can actually easily track what is my top process is grabbing away all my resources. If there's a hidden program that's actually running there, it eats up a lot of your resources, you can use top to see that. For example, Zoom right now is the most expensive process. It took up a lot of memory. You can see that. Zoom is actually not a lot of CPU, but a lot of memory. But Zoom actually taking a lot of CPU as well. I'm not sure I have this, but in Linux, you definitely have htop. Okay, htop is different. So top is looking at all the process, and htop is actually giving you the hypervisor. Hypervisor means that, I mean, this computer, I have multiple core. In this, I think I have a 4 core. And so this actually show me each of the core. So top and htop. The modern computers should all have this, so you can actually see whether I'm utilizing the memory. You can see that I totally have 8 GB of memory, but within all this program I'm running, I'm actually used that about 3.8 GB. So I'm using about 50% of my the physical memory. But each of the program listed here will get a virtual memory. In this example, because I'm actually, I think my architecture is 6260. How do I get out? Okay. If you do a uname, this is Darwin and Arc. Oh, I'm actually 32-bit computer. i386 is a 32-bit computer. So this one is 32-bit operating system. It's actually giving me each of the programs should get 4 GB of memory. Okay, so this tell you some tool. I'm showing you 2 tools that you can use. Actually, four tools. Number 1 is top. Number 2 is htop. Number 3 is uname. Uname basically tells you what operating system you're using. Arc is telling you what's the hardware architecture. So with top, htop, uname architecture, you can actually know a little bit about the system you're running. Okay, let me actually get back to here. So now I want to tell you what is the segmentation fault, which is you're already seeing that. I believe you're seeing a lot of this from homework assignment number 4 as well. Okay, I probably should tell you a little bit about how your program really start running. So when you compile your program, you're actually generate something called a.out. You probably know, some of you, because the makefile I provide is no longer called a.out, it's called HW3 client or HW3 server. It's a program executable. That's actually a executable file stored in your hard disk. So when you run this program, essentially a big portion, except what we call header or magic number. So this tool for the runtime support to recognize whether that is an executable program. If you don't have this, the system knows this is not an executable program. They will just quit. But assuming they realize this is a program, they actually move this map to your real memory in the lower division. Lower division means that below heap. Okay, so just tell you that this is a typical way people do. I would say Linux, FreeBSD, Mac, or Android, they all use the same thing. And in fact, I think iOS is the same thing. Basically, all of them are inherited from the original AT&T Unix model. This is what's developed. Originally, the architecture was developed in around 1970 by AT&T Lab at that time. Okay, but one thing I want to tell you is that this architecture, you see that the lowest memory bytes here is not 00000. It's actually 0001000. We skip a page. Okay, so essentially when we arrange the address, we have to, you think about that. When you want to execute a program, you have to allocate different usage of memory, different virtual address. And when you take ECS 150, you will learn how they can actually manage, translate that virtual address to a real address. But programmers' perception to the system is always just virtual address. So when I print that address, I show you, and that's virtual address. It's never a real hardware address. It's just a virtual address, and the system will do some translation to a real address. That's the issue called memory address mapping or virtual memory management. We're not going to talk about that today. But with that virtual address, you will see that it's started with 0001000. So we skip a page. We skip a page. And this is actually very interesting design, why we actually skip a page. So historically, the programming language C was developed by the same team that developed the Unix operating system in AT&T Bell Lab. At that time, it was called AT&T Bell Lab. And then they split. So the company split, that's why it became AT&T Lab and Bell Lab. It was called AT&T Bell Lab from the beginning. And the people who developed the system, they're C programmers. So essentially, the whole architecture was designed to, I should say the other way, the C programming language was developed to facilitate the development of this operating system. So most of today's modern operating system, the language they use is basically C, using C language to do that. So there was a historical tie there. Anybody want to guess why I skipped this page? Yes. Yeah, exactly. So that's very good. I appreciate that. So essentially, the most commonly mistake that we made, okay, that's not all the mistake we made about memory access, is actually we access the null pointer. Essentially, anytime you try to access a null address, so means that if you look at this design, you will realize that nobody should try to retrieve the content of the address that actually started with 0000080, because any valid content, it will start with 0001000. You skip a page. Then one page is 1K, remember, essentially. This is a concept called page, means that we separate the memory into a number of chunks of memory, and each chunk is 1K page. Okay, so essentially the first chunk should never be used. So that's why anytime you try to reference the address, what do I mean by reference the address? You can actually say the address, but anytime you try to retrieve the content being stored in that address, then you will have trouble. That's called segmentation violation. So realize that this particular segment below here is not accessible. So anytime that you have this issue, that's actually your app. Okay, the step you should do is first to determine the statement that's actually trigger the segmentation violation. Okay, by the way, I want to ask you a question. How do you actually know if your program have a segmentation violation? How do you know which lines of code is actually triggering that? How do you know? So let me ask a more like a precondition question. How many of you actually experienced segmentation violation before? Okay, a lot of you have, and the rest of you, we hope you will experience that today. Okay, all right. Thank you for your hands. Well, this is another thing I want to share with you. When I help you interact with you, I actually realized I saw myself from how you reacted to some of the error message. Let me actually discuss a little bit about myself, the psychology of a programmer. So I'm the kind of programmer which I hope I can write a perfect program the first time. And I never have to see that. Any kind of error message. If you give me like 3 lines of error message, I'm okay. I just bite my teeth and then I will swallow that. But if you give me 300 lines of error code, error message, I'm usually very disappointed. I don't want to write program. I don't want to be a programmer anymore. I don't want to look at those. That's just me, psychology, okay? And I saw a lot of you have shared the same feeling that when we deal with this. So number one, I just want to encourage you that we as a programmer, that's our, I should use the word, that's our blessing. We should actually, whenever you celebrate the Thanksgiving, that you never say that, but this next week you can say in front of your family, it's like, oh, I'm so thankful that the system I'm using gave me 2025 lines of this kind of error message. So teach me to learn. So I'm a little bit kidding about that, but that's the attitude I hope we all embrace. So essentially, those message is actually producing by a huge system. That's an intent for me to know more about what's wrong with the system. So usually the hint number one is usually don't look at 2000 and whatever, how many lines of error message you got. Usually try to scroll back to look at the first line. The first 5 lines is probably all you care at that moment, because after you take care of that 4 or 5 lines, the rest of them might actually go away. because of that. Okay, so having said that, that was just my coaching moment about a programmer's psychology. Okay, we have to just embrace that. Okay, don't be discouraged. I know some of us discouraged, including me. I got discouraged as well. So we just feel happy whenever compiler tell us something like that. All right. So number two, how do you actually know if the first line is a segmentation fault in your pro? Okay, sorry. There is a one type of error is syntax error G++ give you, but when you run the program, you're going to get a segmentation fault. So now I'm actually saying, okay, that's a message saying that well, your program has some memory access error. They're accessing most likely to this page. So you know your program access to this page. But how do you know where it is in your source code for you to actually be able to quickly identify the line of code that's actually triggered the violation and then so you can solve it. How do you know that? Yeah. Okay, so you're using Debugger, right? Using Debugger is a good way because Debugger is actually going to help you to identify. Okay, so there are multiple strategies to deal with that, but I think using the Debugger is the best one. Debugger is designed to reveal a lot of information for you to actually track down not only where it is, but how you get to that point and what's the variable. And you can, in fact, at that time, you can actually print out a lot of historical information about which, not only the location, you can probably print out the variable content. Okay, I hope I can give you a more elaborated tutorial on the GDB because it's really, really powerful. The GDB is getting really even more interesting when you debug a parallel program. Because today's program, the reason I have a full core, you can actually use multiple threads to actually be able to ask you, and then that makes the situation even more complicated. But GDB is the one option. Okay, I'm actually going to ask another approach. What happens if you're using MacBook, like what I'm doing, and GDB is not really well supported? You don't have a debugger to support you. What can you do? What? Yes, exactly. We're just printing, right? We basically just insert a lot of what we call debugging statement. It's a printf or cout to print out in each of the important elements. And then we realize that where this location, oh, by the way to do it in the printf is typically not try to insert those statements from the beginning everywhere. It's usually as you develop, you start to add those things gradually. You say, well, this big block of code, I add one here and one here. And then you realize that, okay, the error must be happened in between. So if you have a two print statement, that one of the statement give you an output, but the second statement never show up, then you know it must be happened between those two. And then you actually add more statement, try to narrow down the code. And eventually you will narrow down to a few lines of code. Then you can actually take a look at that. Okay, so the other thing I want to say is about debugging, which you will realize very quickly, is that sometimes neither GDB nor the printf statement gave you the exact location about the root cause of a segmentation fault. So meaning that you have a variable which is somehow is a null pointer, and you know that because you try to dereference that null pointer. And you actually know where that is by using GDB or printf statement. However, you have no idea that why it's null in the first place because it's supposed to be something represent a particular object that you already created earlier. It should not be null, but it's null at that point. So that null pointer is going to trigger your segmentation fault. but the logical error happened way before that. So now what you have to do is you actually need to track that data variable about the value to see, you might need to print more to see when that variable became a null pointer. So doing this, you know, the debugging, regardless you use GDB or using just adding the printf statement, depending on the environment that you have, you gradually will realize, okay, how do I know that this occurred? Okay, this is actually one of the process. It takes experience for any programmer become quickly to be able to identify. Guess what? I don't have a silver bullet to teach you how to do debugging fast. But I know if you actually give yourself enough opportunity to learn how to handle segmentation fault or this kind of bus error, this kind of mistake or logical error, I see a lot of value about a programmer being mature is actually they learn from those mistakes and then they became really experienced. They can really quickly identify what was the issue. Okay, all right. So just very quickly to talk about this pointer. Now this is my summarization about the pointer. There are two different formats. This is it's essentially it's a data type with a star and with a variable name. That's a pointer representation. So I can say integer x. That's just a integer. X is an integer. But I say integer star xp means xp is an address supposed to store an address or pointer to an integer. And then I can do say xp is equal to mx. Okay, so that is the address we're going to do. And then that is the address when I ask you to print for homework assignment number 4, that's actually what you need to worry about. Okay, so essentially what you have is that if the integer is x is stored as 222, then essentially the xp is storing the address, the first byte of the address over there. That's the idea of a C pointer address. Okay, so very quickly, I'm actually running out of time. I want to tell you, I said there are 3 things together. Pointer, address, array. So now I'm going to tell you the array, why array is equivalent to address. Give me 2 minutes. Hopefully I can take care of this review very quickly. So if I have an array, 2-dimensional array, assuming the struct is chess4 and pieces 8 by 8. I have a 2-dimensional array. I can declare like this, but I want to actually really tell you that this is the real representation. The real representation looks like this. If you have an array, it looks like this, and you can actually access the array, of course, like m, x, and y. This is the way you're familiar to access. But I want to tell you that you can actually reference this way. This representation is a pointer representation or whatever, the address representation of the array corresponding to this. So essentially what you did is that m is the address of the first byte of this array. mxy is an array. By the way, how do you actually do that? This is the real memory layout for your array. If I declare array is 4 by 4, so conceptually it looks like it's a 0, 0, 1, 0, 2. But in the memory layout, in the memory box, either on heap or stack, it actually looks like this. Starting the first byte is a 0, 0, 0, 1, 0, 2. It actually provides a linearization about how the address. But the only thing you need to know, what is the column size? That's why column in this case is 4. That's why whatever address m in that case is the address for the first byte 0, 0. That's why m is equal to m 0, 0, m%. That's m. But when you say m, it also represents this address, the first byte of the whole array. And therefore, when you actually access the particular element x and y, is essentially saying m plus x times column plus y. So essentially, I'm actually going through this address, I get that, and then I use the content, the star for that address. So this part, including everything, including this pair of parentheses, is just address calculation about where I can find in this linear array. And then I use a star to actually be able to take care of that. So that's the only way that you can actually, not only way, this is essentially you can see that the pointer and the array, they're actually the same thing, because anything you can use in this format, I can actually use this format to represent. One thing is important, I should tell you. You can actually declare an array like this. You say M, this. Do anybody know if I don't put anything here, what does that mean? Anybody write the code looks like this. So if you have something like this, that means the dimensional array is undeclared. But you need to declare this second one. So essentially, if you declare multiple dimensional array, if it's a one dimensional array, you can actually, you don't have to declare the size of the column because you only have one row. That's okay. But the thing is that if you have a 2-dimensional, 3-dimensional, 4-dimension, you only can have the first dimension undeclared. Everything else has to be declared. The reason is why, now you know, because if I don't have that column, I cannot do this translation. In fact, the compiler translates all your code from here into a code looks like this. If you don't have that number 4, I put it there, I have no way to do the calculation because I don't know the width of your 2-dimensional, 3-dimensional array. I need to know that. So that's why it's important for you to know that how many rows you should skip because you know that column is full. Okay, I'm going to stop here. I think this gives you some idea. This afternoon, I'm going to talk about homework 4. I'm going to leverage some of this, okay? And I will stay here if you have any questions. Give me a second. I want to. Where did I stop? Oh, here. Sorry.